Momentum, how it works. Unlocking words to remember. The momentum of a particle is defined as the product of its mass and velocity. It is important to note that momentum is a vector quantity, meaning it possesses both magnitude and direction. According to Isaac Newton's second law of motion, the rate at which momentum changes over time is equal to the force exerted on the particle. This means that when a force is applied to an object, it causes the object's momentum to change. The greater the force, the greater the change in momentum. The direction of the force determines the direction of the momentum change, as momentum is a vector quantity. Impulse is a vector quantity that represents the change in momentum resulting from the application of a force over a specific time interval. The resultant force causes acceleration and a change in the velocity of the object for as long as it continues to act. When a force acts on an object, it causes a change in the object's momentum. The greater the force applied or the longer the force is applied, the larger the change in momentum. The direction of the force determines the direction of the momentum change. The law of conservation of momentum states that in an isolated system the total momentum of two or more bodies acting upon each other remains constant unless an external force is applied. Therefore, momentum can neither be created nor destroyed. The principle that momentum cannot be created or destroyed is known as the law of conservation of momentum. According to this principle, the total momentum of a closed system remains constant if no external forces act on it. Collisions occurs when one object strikes another. Problems involving collisions are usually solved using conservation of momentum and conservation of energy. There are two types of collisions. Inelastic collisions, where momentum is conserved. Elastic collisions, where momentum is conserved and kinetic energy is conserved. An elastic collision refers to a type of collision in physics where two or more objects collide and then separate without any loss of kinetic energy. In an elastic collision, both momentum and kinetic energy are conserved. In contrast to an elastic collision, an inelastic collision is a type of collision in which kinetic energy is not conserved. In an inelastic collision, the colliding objects may stick together or undergo deformation, resulting in a loss of kinetic energy. This is because some kinetic energy had been transferred to something else. Such collisions are simply called inelastic collisions. Analyze the difference. Take note. Momentum depends on two factors, which are the mass and the velocity of an object in motion. Like velocity and force, it is a vector quantity. The momentum gained by an object or body is equal to the magnitude but opposite direction to the momentum gained by the other object or body. In this system, no momentum is gained or lost. We say that momentum is conserved. Formula for momentum. P equals m times v. P stands for momentum. M stands for mass. V stands for velocity. Let's have a sample problem. Calculate the momentum of a 1200 kg car with a velocity of 25 meters per second. P equals m times v. Substitute the given numbers. Equals 1200 times 25. Equals 30,000 kilograms, meter per second. Is the final answer. Formula for impulse. Impulse equals force times time. I for impulse. F stands for force expressed in Newton or N. T stands for time. Sample problem. If the football halfback experienced a force of 800 N for 0.9 seconds to the north, determine the impulse. Impulse equals force times time. Substitute the given numbers. Impulse equals 800 Newton, 0.9 seconds. Impulse equals 720 Newton per seconds is the final answer. Thanks for watching.